హలో ఎవ్రీవన్. పబ్లిక్ ఎగ్జామినేషన్లో క్వశ్చన్ నెంబర్ 18 మనకు కాంప్లెక్స్ నెంబర్స్ టాపిక్లోంచి ఒక 7 మార్క్స్ క్వశ్చన్ ఫ్రేమ్ అవుతుంది. దట్ ఈస్ డిమోరిస్ థీరం నుంచి కాంప్లెక్స్ నెంబర్స్ అప్లికేషన్. అక్కడ డిమోరిస్ థీరం నుంచి ఒక 7 మార్క్స్ క్వశ్చన్ ఫ్రేమ్ చేస్తున్నాడు, 18th వన్. లెట్ us see ఫస్ట్ క్వశ్చన్. ఇఫ్ n ఈజ్ ఇంటీజర్ దెన్ షో దట్ 1 plus I whole power 2n plus 1 minus I whole power 2n equal to 2 power n plus 1 of cos of n pi by 2. This is the question. Yes, to solve this, what I am doing, observe. Write LHS part. What you have? 1 plus I whole to the power of 2n plus 1 minus I whole to the power of 2n, where n is integer quantity. Here n belongs to z. Next, here inside I am going to divide with root 2 and I am multiplying with root 2. Now apply power 2n here and here. Next, second one, also divide with, multiply with root 2 and now apply exponent 2n. Now what happens, observe. This is 2 to the power of 2n divided by 2. This is cos pi by 4 plus I sin pi by 4 whole to the power of 2n, and here root 2 power 2n written as 2 power 2n by 2. Inside you can write cos pi by 4 minus I sin pi by 4 power 2n. 2 gets cancelled here and here also. If you take 2 power n common, then what happens? Cos pi by 4 plus I sin pi by 4 whole to the power of 2n. Next, plus cos pi by 4 minus I sin pi by 4 power 2n it is. Now applying De Moivre's theorem. De Moivre's theorem says that cos theta plus I sin theta whole to the power of n written as cos n theta plus I sin n theta, where n belongs to capital N. Using this, now here I can write, in the next step it is 2 to the power of n. Inside the bracket we get cos of 2n pi by 4 plus I sin of 2n pi by 4 . Next, plus cos of 2n pi by 4 minus I sin 2n pi by 4 it is. Now these two terms gets cancelled and we get, in the next step it is, this is equal to 2 to the power of n. Cosine angle you have 2 times, so 2 times of cos of 2n pi by 4 this is equal to 2 power n 2 power 1 cos n pi divided by 2. So that what we get, 2 power n plus 1 of cos of n pi by 2. This is RHS part. That's all. Let us move to the next question. Again, n is positive integer. Show that 1 plus I whole power n plus 1 minus I whole power n equal to 2 power n plus 2 by 2 cos of n pi by 4 is given. Again, select LHS part. Yes, I am going to write LHS part. That is given as 1 plus I whole to the power of n plus 1 minus I whole to the power of n. Here I am going to divide with root 2 and also I am going to multiply with root 2 and then I am going to apply power n. Next here divide with root 2 and also multiply with root 2. Now apply power n. What happens? Root 2 power n you can take out. 1 by root 2 plus I by root 2 whole to the power of n plus 1 by root 2 minus I by root 2 whole to the power of n it is. This is 2 power n by 2. Next, this is cos pi by 4 plus I sin pi by 4 whole to the power of n. Next plus, and this one you can write cos pi by 4 minus I sin pi by 4 whole power n. Now by De Moivre's theorem it can be written as inside cos n pi by 4 plus I sin n pi by 4. Next plus cos n pi by 4 minus I sin n pi by 4 it is. These two terms gets cancelled. In the next step I can write this as 2 to the power of n by 2. You have 2 times of cos n pi by 4. Now this is 2 to the power of n by 2 plus 1 into cos of n pi by 4. 2 power n by 2 plus 1 value, that is 2 to the power of n plus 2 divided by 2 of cos n pi by 4. This is your RHS where n belongs to Z plus. That's all. Let us move to the next question. Alpha beta are the roots of x square minus 2x plus 4 equal 0. Then for any small n belongs to capital N, show that alpha power n plus beta power n equal to 2 power n plus 1 of cos of n pi by 3. Yes, this is the question. Okay, right. Given equation first I am going to write. Since x square minus 2x plus 4 equal to 0 implies I can write x square minus 2x plus 1 plus 3 equal to 0 you can write. Implies this is x minus 1 whole square plus 3 equal to 0, and you can write x minus 1 whole square equal to minus 3, x minus 1 written as root over minus 3, implies applying square root here you will get plus or minus, so that we get x minus 1 become plus or minus root over minus 3, that is root 3, root over minus 1 is I, implies the value of x equal to 1 plus or minus root 3 I, and here one root is alpha and the other root is beta. Yes, let us suppose alpha equal to 1 plus root 3 and beta equal to 1 minus root 3 along with I. 1 plus root 3i, 1 minus root 3i are roots here. Next, alpha power n. Alpha power n written as 1 plus root 3i whole to the power of n. And from this alpha power n written as, suppose divide with 2 each and every term, and after that multiply with 2. Now write exponent n. then you can write alpha power n as 2 to the power of n. Next 1 by 2, that is in terms of cos pi by 3 plus I sin pi by 3 next term whole to the power of n. And from this alpha power n become 2 to the power of n. Using De Moivre's theorem, it is cos n pi by 3. This is result 1. Next, let us find beta power n. Beta power n written as 1 minus, this is cos n pi by 3 plus I sin n pi by 3. Result number 1. Okay, next beta power n. Beta you have 1 minus root 3i here. So 1 minus root 3i whole to the power of n implies what we get? Beta power n become, first multiply and divide with 2 and then apply power n on each. Therefore beta power n become 2 to the power of n outside 1 by 2 cos n pi by 3 minus this is just pi by 3. Next I sin pi by 3 whole to the power of n implies what we get? Beta power n equal to 2 power n of, now applying De Moivre's theorem, cos n pi by 3 minus I sin n pi by 3. This is result 2. Now what is LHS? Observe, you have LHS part alpha power n plus beta power n. Alpha power n from 1 2 power n, that is cos n pi by 3 plus I sin n pi by 3. Next beta power n value 2 to the power of n cos n pi by 3 minus I sin n pi by 3, that is. Here from both, if you take 2 power n common, we get cos n pi by 3 plus I sin n pi by 3. Next plus cos n pi by 3 minus I sin n pi divided by 3. These two terms gets cancelled. We get 2 power n multiplied by 2 cos n pi by 3 it is. So that 2 power n plus 1 of cos of n pi by 3. This is RHS part.